Okay, let's look at problem 4A here. And the circuit is shown on the screen. And the question that we are asking is, okay, what should the bias voltage, VBE, be so that the VCE is at 3.2 volts? So in this case, you can just assume that VBE is not there. Okay, so this voltage is equal to 0, the small signal voltage, and we're just looking at the bias voltages. And you can see that in this question, it's not very easy to solve the problem because we're asking for VCE, uh, and and that particular VCE, we are not able to calculate any currents here, right? We can calculate VB because this is 0, so this can be 0.7, but we can't really calculate the emitter and the base currents. So what we would have to use is what is called the exponential model uh, of the transistor, and the relation that tells us that the collector current is equal to Is times e to the power v, let's say VBE, divided by VT. We've been given the value of Is in the problem, and VT is always equal to, or you can assume it to be 25 millivolts. Okay, so basically what we want to do is we want to calculate IC and then calculate VBE using this equation. So what is the value of IC here? So we know what VCE is, which is 3.2 volts. And if that is 3.2 volts, so IC will be equal to VCC minus VCE divided by 6.8 kilo ohms. So that's 10 minus 3.2 divided by 6.8 K, which turns out to be 1 milliamperes, right? So we have IC is equal to 1 milliamperes. And now you substitute this value of IC in this equation. So what do you get? So 1 times 10 to the power minus 3 equal to Is. What's the value of Is that we've been given? We have been given 10 to the power minus 15. And then you have e to the power VBE over 25 times 10 to the power minus 3, right? And you should be able to calculate the values here. So how do you do that? So let's do the mathematics. So 10 to the power 12 equal to e to the power VBE divided by 25 times 10 to the power minus 3. You can take the logs on both sides and you can calculate VBE, and it should turn out to be equal to 690.8 millivolts. Right, so usually we assume VBE to be zero point 0.7 volts, which is 700 millivolts. But exactly in this case, VBE is equal to 691 millivolts or so. Okay, so that's the first problem.